Good morning, third grade. It's Mrs. Selfridge here. Today we're going to continue on in our books and go on to Chapter 12, Lesson 5. You guys are doing a great job. We're going to talk about drawing and analyzing line plots. So if you guys can go ahead and get out your math books and turn to pages 715, 716. Helper is with us this morning. Yep, there she is. Okay, we're going to move on. Here we go. Hopefully you did okay yesterday on your homework. All right, Albert spun a spinner, kind of tricky to say, 16 times to see how often the spinner landed on each number. Display the data in a line plot. So we're going to draw and label a line plot, and the line plot includes all the values of this, okay, and we're going to give it a title. So we're going to include all the values of the data. We're going to start with 0 and go to 4 because I don't see any numbers higher than 4 here. Okay, we're going to give it a title. And here is an example that we're going to use. Albert spun a spinner 16 times to see how often the spinner landed on each number. Display the data in a line plot. So we're going to draw. So here's what we did. We have the 0 to 4. And we're just going to draw an X above the number for each result. So when you look back at your information on the other page, let me see if I can go back here. You had these numbers. So I'm just going to go through my line plot, and you can either go down the rows or you can go across. Don't just go up and down though. So maybe I'll start here. How many zeros do I have? I'll put an X above a 0. How many 1? I've got a 1 there, so I'd put an X above the 1. Got a 2 here, so I'd put an X above the 2. Got a 1 here, so I put another X above the 1. You're just going to keep doing that until you use up all those numbers from that chart, okay? We're going to analyze the line plot, and we're going to write a sentence that interprets the data. Again, that sentence could be different for everyone. We just have to make sure it's accurate, okay? And these 3 X's represent the 3 times the number 2 was spun. All right. So Albert spun a spinner 16 times to see how often the spinner landed on each number. Display the data in a line plot. Draw an X above the number for each result. Complete the line plot by drawing the remaining X's. Okay, so he spun the spinner 16 times. Okay, so if you counted these X's, there should be 3 here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 X's there, right? Draw an X above the number for each result. That's what they did. Complete the line plot by drawing the remaining X's. Okay? And the sentence we could write for this is the number 1 was spun more than any other number. It's easy to see, isn't it? Okay. Use Albert's line plot to find the differences between the greatest number of X's and the least number of X's. Well, when you look at your line plot, the tallest one is your greatest, that has the most, right? And the least, there's actually 2 here. So the number spun most often was 1. Okay, and how do you know that? Well, the greatest number of X's is above the 1. And how many times was the number 1 spun? You just have to count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Use Albert's line plot to find the difference between the greatest number of X's and the least number of X's. So we need to find numbers spun least often. What numbers were spun least often? These 2, right? So you'd write in a 3 and a 4. And then the difference between the greatest number of X's and the least number of X's is, what are we going to write there? Okay, so we'd write 3 and 4 here. How many times were each of these numbers spun? 1. The difference between the greatest number of X's and the least is 8 minus 1 equals 7. Display the set of data in the line plot. Okay, so we have all this data right here, and we need to put it down here. Now, remember X's, and make your X's kind of small and nice and neat. You want to make sure you have a sharpened pencil to do these, otherwise it looks like a mess. Okay, so you take that information, you bring it down here. We have 1, number 2. How many 4s do we have? 2, so we put 2 X's above the 4. How many 5s do we have? 2, 1, 2. You can see all the information just transferred down here. Now a little time for you to practice. So display the set of data in the line plot. So what's the conclusion you can draw from this? So you're going to take all this stuff that's right here and put it over here. Okay, we're going to put the siblings down here. So we put a 0, a 1, a 2, a 3, and a 4. Okay, and then we probably ought to put a 5 here or more. Then you're going to put your X's above here. Let me show you this one and then we'll let you do the next one on your own. Okay, and then a sentence we can write. Most of the students have 2 siblings. Would you say that's accurate? I would. Okay. Pause the video anytime if you need to. All right, for exercise 3 and 4, refer to the line plot below. So they've already filled this one out for you. You just have to answer a question. How many students' quiz scores are recorded? Explain. Give you a hint. You're going to need to add up your X's. Do that real quickly and then let's see if you get it right. You should have answered 12 students. All you needed to do was count the X's. All right, for exercise 3 and 4, refer to the line plot below. What's one conclusion you can draw from this line plot? You may come up with something that we don't have here. As long as it's accurate and true, it's fine. This is the conclusion they came up with. Most of the students scored 92 or higher. All right, circle the true sentence about each set of data. Looking at this data, are all students are 55 inches tall? I don't think so. Look at the next one. Half of the students are 52 inches or taller. You have to figure that out. Add these up. 1, 2, 3, 4, 5, 6. That one could be true. Most students are 51 inches tall. I don't think that's true. I think it's only the middle one. What do you guys think? Oh, we were right. All right, circle the true sentence about each set of data. So you have to go through and you have to check and see which one's true. Okay, I'll give you a second. Try to do it on your own, then turn this back on and see if you get it right. Most teachers taught for 7 years or more. Hopefully you got it right. All right, use symbols. Compare the number of members who are 6 or 7 years old and the number who are 8 and 9 years old. Use greater than, less than, or equal to. So you have to add up the amount of members that are 6 and 7, add up the members that are 8 and 9, and put a symbol in the middle. Hopefully you figured out that 5 is less than 7. Okay, give an example of a set of data that would not be best displayed in a line plot. I'll give you this one. Set of data with numbers of a high frequency. Okay, too many X's. We don't want to draw 64 X's on the number 7. Okay, that's just too many. All right, how can I interpret the data you have collected? Here's what you can do. You can look at labels, title, scale, or key, compare and look for differences and similarities, and make conclusions. All right, time for you to get started on your work. I am so excited. I am recording this on Tuesday, and hopefully I'm going to be able to see some of you today and drop off your books. I miss you guys. I hope you're doing great things. We're going to keep going in math because you know Mrs. Selfridge loves math, and we are having fun, and I think we can get a little further in our book. All right, take care. Miss you guys. Keep doing great things. Bye.